Welcome to this explainer on network infrastructure intelligence. If you've ever found yourself wondering exactly how cyber investigators, threat analysts, or frankly even hackers manage to map out the hidden technical layers of a target organization, well, you are definitely in the right place. Today, we're going to totally demystify how we can map hidden internet infrastructure, and we're doing it using only publicly available data. We're going to build this really comprehensive, repeatable workflow that takes you from just a basic, everyday domain name all the way down to the actual physical servers and network pathways that make it all function.
Here's our agenda for today. We're kicking things off with the OSN reconnaissance phase. Then we'll move into unmasking domains in DNS, tracking IPs and hosting, analyzing certificates in internet history, corroborating our evidence, and we'll wrap it all up with a complete investigative workflow.
Okay, let's dive right into Section 1, the OSINT reconnaissance phase. So I want you to consider something for a second. When you type a web address into your browser, how much of that organization's actual digital footprint are you really seeing? Well, the truth is, the websites we browse every single day, they're really just the tip of a massive hidden infrastructure iceberg. For every single page you see, there are all these complex routing protocols, background servers, hidden subdomains, and historical records just lurking out of plain sight. It's kind of like this. Everyday users are basically just looking at the bright, flashy neon signs on the street. That's the public-facing surface web. But investigators, we're tracking the massive, interconnected back-end network hidden in the dark alleys behind those signs. We aren't really interested in the flashy graphics on a web page. We're looking for the foundational architecture that supports the whole shebang. And to do that, we rely on a very specific methodology.
That methodology is called open source intelligence, or OSINT for short. Put simply, OSINT is the process of searching for, gathering, and analyzing data found entirely from public sources. So no hacking involved here, no stolen credentials, no secret government databases. But there is a totally crucial distinction we need to make right out of the gate. Raw open source data is, well, it's just data. It only transforms into actual intelligence when it's properly processed, corroborated, and analyzed by a human investigator. Now, the sheer scale of information you can find without any special security clearance is, honestly, mind-blowing. The OSINT framework maps out tools to search across dozens of different data categories. We're talking everything from domain names to IP addresses, right down to public business records. It's absolute proof that a massive amount of sensitive infrastructure data is just sitting out there in the open, just waiting to be connected by someone who knows where to look.
Moving right along to Section 2, unmasking domains and DNS.
All right, so the domain name system, or DNS, is effectively the internet's phone book. We humans remember names like CNN.com, but computers communicate using numbers, specifically IP addresses. DNS translates between the two. You've got A records that point to an IPv4 server address, MX records handling email routing, TXT records providing verification, and CNAME records acting as aliases. And using really simple command line tools like dig or NSLOOKUP, investigators can pull all of this in seconds. Meanwhile, WHOIS records are basically the property deeds. They tell us exactly who registered the domain and when.
But of course, there's a catch, right? Thanks to modern data privacy rules like GDPR in Europe and just the widespread use of privacy masking services, looking up a current WHOIS record today often just gives you the name of some proxy company. But as investigators, we have a workaround. We pivot to historical query tools, things like WHOISI or View DNS Info. Because domain ownership changes over time, searching the historical record can very often reveal the true original registrant's name, their email, or even their phone number from before they ever enable that privacy shield.
Which brings us to Section 3, tracking IPs and hosting.
Okay, so an IP address is essentially the specific street address of a device on the internet. But to actually route traffic between massive networks of these IPs, we use autonomous systems. Think of an autonomous system number, or ASN, as the identifier for a specific internet service provider. These systems talk to each other using BGP, or Border Gateway Protocol, advertising the absolute best paths for data to travel. By using tools like Shodan, which is basically a search engine for internet-connected devices, investigators can reveal the ASN an organization uses, figure out their physical locations, and even see exactly what communication ports they've left wide open. Now, during this phase of an IP investigation, you're frequently going to run into a pretty major hurdle: content delivery networks, or CDNs. An organization might have direct infrastructure, meaning their domain points straight to their actual web host. But increasingly, they use masked infrastructure. They'll place a service like Cloudflare right in between the public and their server for a boost in security and speed.
If you query their IP, you're just going to get Cloudflare servers. So, a skilled investigator has to use advanced OSINT techniques to bypass this CDN masking to identify the true underlying origin server and who's actually hosting it.
Let's transition into Section 4, Certificates and Internet History.
One of the absolutely most powerful yet somehow still overlooked tools in OSINT is SSL and TLS digital certificates. These are those cryptographic ID cards that give websites that little padlock icon in your browser, ensuring secure communication. And because of certificate transparency logs, which are public databases recording literally every certificate ever issued, investigators can query tools like crt.sh or osint.sh. If you search a main domain there, it reveals a massive list of hidden subdomains. It exposes internal development servers, overlapping infrastructure across entirely different companies, and even highlights when their security certificates are getting dangerously close to expiring. It's a real goldmine.
But what if the infrastructure we're trying to find has already been deleted or changed? Well, that is where Internet History comes in to save the day. By firing up the Internet Archive's Wayback Machine, we can actually view the visual state of a website exactly as it looked years ago. We can also leverage passive DNS databases. See, passive DNS systems constantly record how IP addresses and domains map to one another over time. So if a threat actor used a specific server 3 years ago and then smartly tried to change it, passive DNS remembers. We can literally turn past infrastructure changes into current, actionable evidence.
Next up, Section 5, Corroborating Infrastructure Evidence. To pull all this off efficiently, professionals rely on specialized tools, and each one has a very specific primary purpose. Shodan, as we mentioned, scans the internet for open ports and vulnerable devices. Maltego is incredible. It takes all this raw data and maps it out visually, actually drawing lines between connected pieces of infrastructure. Then you've got URL Scan, which acts like a safe little sandbox. It analyzes the underlying technologies of a website without us ever having to actually visit it and accidentally tip off our target. And Dehashed? That checks if any associated emails have been caught in historical data breaches. Remember, using a combination of these independent sources is absolutely crucial.
I want to pause here for just a second and remind you why all of this matters so much. The reconnaissance techniques outlined in the MITRE attack matrix prove that threat actors and cybercriminals, they are using these exact same tools to plan their attacks. This is exactly why organizations have to proactively map their own footprint from the outside in. Because look, if you don't know what ports you've left open or what subdomains are silently leaking data, an attacker will very gladly find out for you.
And finally, Section 6, the complete investigative workflow. Let's put it all together.
So the big takeaway here is that successful OSINT is never just random guessing. It's a highly disciplined methodology. Step 1, identify your target clearly. Step 2, collect those DNS records and analyze historical WHOIS data to find the true owners. Step 3, investigate the IP addresses, look up the autonomous system numbers, and bypass those CDNs to find the physical hosting infrastructure. Step 4, review historical states using the Wayback Machine, passive DNS, and SSL certificate transparency logs. And finally, Step 5, corroborate all of your findings across multiple, completely independent platforms. Throughout this entire workflow, you really need to keep this cardinal rule of OSINT in mind. Data is just data until analyzed. Never, ever rely on a single indicator. IP addresses can be spoofed. WHOIS records can be totally faked. VPNs can mask physical locations. This is exactly why no single piece of data is ever conclusive on its own. You've got to cross-reference your findings. It's really only when multiple, independent points of data align perfectly that you can confidently call it intelligence. Well, we have covered a whole lot of ground today, right? From the bright neon signs of the surface web all the way down to the intricate routing protocols of hidden infrastructure. So I want to leave you with one final, provocative thought. If a skilled investigator applied this exact workflow to you, right now, what would your organization's digital footprint reveal to the outside world? It's a pretty heavy question, but it's one every single security professional absolutely must ask themselves. Thank you so much for joining me on this explainer, and remember to keep exploring those hidden layers of the web.